Hello and welcome to the Town and Country restaurant video, which is part of the 3P series. As usual, please make sure that you have your book related to this video, coloured pencils and pen. So let's get started. In this video we'll be looking at the following control structures and variables. These are the for and while loops and records and arrays. Please spend a few moments looking in your programming booklet and reminding yourself about these structures. Here is a reminder of how to declare an input in an array. When declaring an array, we have the name of the array, mark list, followed by an equal sign, then the data type of the array, int, followed by the name given to the elements in that array, student. The X represents the number of elements in the array. On the right hand side of the slide we see an example of how to put data into an array. In this case we know how many elements are in the array, 25, because we start counting at 0. Therefore we can use a for loop as we know how many loops we're going to need. Look carefully at the input line and see that there are two different pairs of brackets used. Square brackets surround the name of the elements. Round brackets encompass the name of the array and the name of the elements. Please try and remember this. Also take note that when we are inputting data into an array using a for loop, a counter is not needed. Here is our record structure again. This time look at the while loop. We could have used the for loop and written for x 0 to 14. A while loop is just as efficient. In the while loop we are putting 15 records of data into the employee record. We are needing to use a counter with the while loop. With our checklist, read the question on page 1 of your booklet at least twice. Coloured pencils are used to annotate and highlight the inputs, processing, outputs and important information. Spend a few moments doing this and then compare your annotation to mine on the next slide. Here is my annotation. Please make sure yours is the same. Also take note that there are 4 waiters or waitresses waitering for the restaurant, as there are 2 in each section. Now, complete the requirements and the table on page 2. Spend some time thinking what control structures you will need, i.e. what type of looping is going to be needed. When you are ready, my completed requirements and table are on the next slide. Here are my completed requirements and table. We could use a for loop in this question as we know the number of waiters and waitresses. Now we are on to our checklist at the bottom of page 2. Think about what parts you're going to need to solve this question. When you're ready, move on to the next slide to see my suggestions. Here are my suggestions. The local variable has been highlighted as we will have an x equals 0, which is ensuring that any residual data is cleared and the inputting of data will start with the first record. As always, please make sure that your checklist is the same as mine, then we will be ready to write the code. Before we look in detail at this solution, the overview is that a record is opened and the contents of the record are placed into 3 different arrays. Let's see how this is done. We start off with the name of the module called module load. The parameters in the module are the 3 arrays. Waiter ID, waiter FN, first name, and waiter LN, last name. After the title we have a keyword begin, then the record is declared showing the name of the record, the various fields in the record, and each record showing its data type. Those with a string data type will also display the field length. The record declaration is finished with the keyword end type. The record can now be opened and the local initialized variable x is used to clear away any residual data and ensure that any inputting is going to start with the first record. The for loop loops through 4 times. As we saw from the problem, there were 4 waiters or waitresses. Have a close look at the inputs and notice the different bracket types which we pointed out at the beginning of this video. After the inputs, we close the for loop. Since we're using an array in this loop, no counter is necessary. We close the record and end the module. On this slide, you see an alternative solution. We have a while loop which only finishes when we reach the end of file, which is a better solution as it allows for more waiters and waitresses if the current situation were to change. There is a field for each field in the waiter data record. Each element in each array is populated with data with each loop until the end of file is reached. Either solution is correct. You decide which one makes most sense to you. Can you write down both solutions on page 3 of your booklet? You will find this question on page 4 of your booklet. Read it through carefully at least twice. As we have done with all problems, annotate the text to show the inputs, processing, outputs and important information. Then on page 5, complete the requirements and the table as well as highlight the elements you will need in your checklist. On page 6, write your pseudocode. By all means, use the exercise we have just done to help you with this problem. When you've written your pseudocode, the answer will be on the next slide. Here you can see we have used a while loop to input the 3 arrays: table area, table description and table capacity from the record data, table data. Please make sure that this solution is written down on page 3 of your booklet. Now on to something very new. In the next few slides I'm going to show you how pseudocode can sort data. There are various methods of sorting data. The bubble sort is one of the most straightforward. A parse is the computer program looking at each number in the array and deciding if that number needs to be swapped with the number immediately after it. Once the program has looked at all of the numbers in the array, that is the end of a parse. At the end of the first parse, what will always happen is that the highest number will always end up furthest to the right, as you can see with the number 8. After the first parse, all of the numbers are not yet sorted, so a second parse is needed. Let's have a look at the second parse. The same method is used. The program will look at each value in turn and decide if the current number needs to be swapped with the next number immediately after it. At the end of the second parse, the second highest number will be left just before the highest number. This makes the sorted part of the array gradually become a larger group. The reason we call this method a bubble sort is that the numbers will float to one end of the array. You will also see that the end of the second parse takes one less swap than the first parse, as the code, which we will see shortly, does not need to look at the last 2 values in the array, as we know that they are sorted. On to the third parse, and if you follow each swap, by the end of the third parse, all of the numbers are in the sorted group, going in ascending order from left to right. Though we can see the numbers are sorted, the computer still needs to go through the final parse before the program is completed. From this diagram, there are 2 mechanisms in play here. The first would be code to ensure that for each parse, 1 less swap is needed each time. The second mechanism is the swapping of the values themselves. This must also be programmed not to swap the last value in the array each time. Let's focus on the 2 nested for loops. It may look a little intimidating, but we'll unpack the code so there's nothing to fear. As you have seen in the previous slide, the sorted group gradually gets larger after each pass, which means there is less to sort with each pass. So, efficient code is needed to make sure that the program does not have to look over values that have already been sorted. To do this, we use two nested for loops. The first for loop is concerned with the passes. So, what the pseudocode is saying, start with the first swap and keep looping. But with each loop, do one less final swap each time. This reduces the number of values that can be swapped with each pass. The second for loop focuses on the actual swapping of the values during each pass. Here again, this for loop says keep swapping numbers except the very last one in that pass. Therefore, with each pass, the code will automatically swap less values, because with each pass, more values have been sorted. Okay, now this line of code. You could probably explain it yourself. What it is saying here is if the preceding cell has a higher value than the next cell, these values need to be swapped. So, if cell 1 or the first element has a value of say 5 in it, and the second element, which would be cell plus 1, has a value of say 4 in it, then the first element is more than the next cell and needs to be swapped. This section has a lot going on because there are 3 arrays all being involved in this bubble sort all at the same time. Let's make this easier to look at and focus on just one array, the area number array, and see how this code works. There are 3 values being used here. Area number, square bracket cell, which contains the value 3. Area number, square bracket cell plus 1, which contains the value 2, and temp. In the first line of code, we see that if the area number, square bracket cell, value is greater than area number, square bracket cell plus 1, is true, then the remaining code is going to be used or executed. Let's see what the next line of code, temp equals area number, square bracket cell plus 1, does. As you can see, the area in area number, square bracket cell plus 1, becomes the temp value. Now let's see what happens when area number, square bracket cell plus 1, equals area number, square bracket cell, is executed. What was in area number, square bracket cell, becomes the value in area number, square bracket cell plus 1. Now we are on to the last line of code, and I would imagine you know what is going to happen here. Let's have a look. So, what has happened using these 3 lines of code after the if statement is that these 2 numbers have been swapped, which I think is pretty clever. On page 7 of your booklet is this question. Complete the question at the bottom of page 7 to start with. As you have done with all of your questions, work your way through the tick list, annotate, complete the requirements table and checklist, then on page 9, write your pseudocode. Before you hand in this booklet, please make sure that all the work has been done. Then hand in this booklet to me. Thanks for watching this video. Goodbye.